Okay, in this section, we're going to be looking at the remainder and factor theorems. The basis of both of these theorems has to do with division of polynomials, so we're going to start our discussion there. I'm going to review two different types of division. Long division, which you may remember from the previous course, although we are going to concentrate on synthetic division in this course. You will use long division in your subsequent courses, so I want to go over it just so you don't lose those skills, but as I said, we will be concentrating on synthetic. Okay, so to begin with long division, you're asked to find the quotient, you're given a dividend, you are going to divide by 3x minus 2, and I'm going to review the steps for you. It's just like doing long division with just numbers, only of course you have variables here. So the dividend is going to go inside this box, which I have set up here, and the divisor is going to go on the outside. When you are doing division of polynomials, you have to make sure to put the terms in descending order. So in other words, highest power, then the next highest power, then the next highest, and so on. And then the divisor should be arranged like that also. This one already is. So I need to rearrange these terms. I'm going to have my cubed term as the first term, and I'll slide this up in a minute. Let me just copy the terms. It's going to be 6x cubed. Then I'm going to have my squared term. Then I'm going to have my 5x. And then I'm going to have my positive 4. You also want to make sure that when you're setting up your terms in the dividend, that you are not skipping over any powers, that they've given you a polynomial where none of the powers are missing. Notice that we begin with power 3 and then it goes down in increments of 1, and that's exactly how it should be. If you are missing any of the powers, you're going to insert what's called a dummy variable, just sort of a space holder so that all of your terms line up. Our divisor goes out here. And I'm going to explain the procedure you're going to use to get the quotient and the remainder if there is one. Okay, so you're going to start always by looking at the leftmost term in the divisor, just the 3x, and the leftmost term in the dividend. And you're basically going to ask yourself this: 3x times what will give me the leftmost term in the dividend? Okay, the answer to that is 3x times 2x squared is what gives you 6x cubed. Because remember, when you're multiplying, you add powers. So if you only have x to the first degree and you're trying to get to x to the third degree, you need an x squared. And if you want to get a 6, being that you only have a 3, it would be 2. So you're going to multiply by 2x squared. That goes right here. Okay, so that's your first step. You ask yourself, what do I multiply this leftmost term by to get the leftmost term in the dividend? Second step, you're going to take what you just got, the 2x squared, and you're going to multiply it by the entire divisor. I'll just kind of give you a little doing over here. Okay, so you're going to multiply 2x squared times 3x. Remember, I'm multiplying everything here, just like it says here, times everything in the divisor. So 2x squared times 3x would be 6x cubed. And then 2x squared times negative 2 would be negative 4x squared. Okay, third step, you're going to subtract that bottom row, the entire polynomial on the bottom row. Okay, if you're going to subtract this entire polynomial, that means that you are switching the signs of everything in the polynomial. That's what it means to subtract. I think you should circle your switched signs so that you pay attention to them. This 6x cubed is presently positive. If I switch it, it'll be negative. This is negative, the 4x squared, so I'll switch it to a positive. And it is those switched signs that you are going to use to add the bottom row to the top row. you're going to add the bottom row to the row above it. And you're going to bring down one extra term so that you can repeat these 4 steps, but with the new numbers. Bring one extra term down. So you have the book giving this course. This is how they've said it, and I'm giving it in my own words. So you can look at either one, whichever works for you. Okay, so we were about to subtract. We had done so by switching the signs, and we're going to combine or add the bottom row with the top row. So 6x cubed combined with negative 6x cubed, that's what it means to add. You're just combining. These will always step properly. They should always cancel that leftmost column. Negative 1x squared combined with positive 4 is 3x squared. So I've combined the top row with the bottom row. And I'm going to bring down one extra term. Okay, these steps that you just went through, do them all over again. So we're going to repeat with the new number. So again, you're going to go. If you go through these steps again, you're going to look at the leftmost term here and the leftmost term here, and you're going to ask yourself, 3x, the leftmost term in the divisor, times what is equal to 3x squared. What do you multiply this by to turn it into this? So you would have to multiply this by x in order to turn it into an x squared. So that is what you're going to multiply by. So it's going to be this new term that you got in the divisor. Every time you get a new term, you multiply it by the entire divisor, just like I did in step 2. Every time you have a new term up here, you multiply it by this entire divisor. Okay, so x times 3x is going to be 3x squared. X times negative 2 is negative 2x. Then next is the subtraction step. I'm not going to write out all those words because that'll just be too much. Let me slide this up a little bit. Okay, so we're going to subtract. Remember, when you're subtracting that entire bottom row, that just means switch the signs. Be sure to circle them so that you pay attention to them when you go to do this step, which is to combine. We're going to combine rows, the bottom row to the row above it. So positive 3 combined with negative 3 on your x squared term is going to cancel. Negative 5 combined with positive 2 is negative 3x. And don't forget, an extra term. And then bring down an extra term. I don't think I have any more room to write out the steps, but you can watch me continue the steps. So I've just brought down that last term, and you want to keep repeating. Leftmost term here, you're always concentrating on the leftmost term here and the leftmost term here. Can I multiply this by something to turn it into this? And you can. You can multiply 3x by negative 1 to turn it into this. So that will be your third and final term in your quotient. Okay, now remember, every time you get a term in the quotient, you will multiply it by everything in the divisor. So it'll be negative 1 times 3x, negative 3x. Negative 1 times negative 2, positive 2. Don't forget that subtraction step. You're subtracting the entire bottom row, which really just means switch the signs of each of those terms and then combine it with the row above. So negative 3 plus 3, that cancels. Positive 4 minus 2 is 2. And now you can't go anymore. There's no way to multiply 3x by anything that would turn into just a 2. So these are the names of everything that is here. This is called the dividend. What's underneath the quotient symbol? or the division symbol, excuse me. This is called the divisor. This is called the quotient. And this is called the remainder. Okay, it's hard to follow instructions when you don't understand the vocabulary that's being used. So I like to go over these words: dividend, divisor, quotient, remainder. Okay, so if they ask you what is the quotient is the 2x squared plus x minus 1, and the remainder would be written like this. Whatever sign it has, it's positive, over the divisor. That's how a remainder gets written, the remainder over the divisor. And that is your completed answer. Okay, so just a little review of long division. I know it's long, but thank goodness you're going to be concentrating on synthetic division in this particular book, in this section. So let's try this one more time. Don't forget, you need to have these in descending order, and none of the powers should be missing. Otherwise, you should put in a space holder, what is sometimes called a dummy variable, in order to make all of your like terms line up. Okay, so here we go with our division box. We have a 4th degree term. We have a 3rd degree term. We don't have a 2nd degree term, but yet I'm going to get 2nd degree terms when I go to do the division, so I need to have something to line it up with. So let's say here's my 2nd degree term, and I have 0 of them. That's what we call a space holder or a dummy variable. We do have a 1st degree term, and we do have a constant. Okay, then the divisor is 3x squared minus 2x. Okay, so let's begin again. I'll write out the steps for as long as I have room, but we're really doing a repeating of this 4 steps, just using different numbers each time. So we're going to start off. Remember, you're always looking at the leftmost term in the divisor and the leftmost term in the dividend. And you're asking yourself, what do I multiply 3x squared by? What do I multiply 3x squared by? This will be my first step, in order to get 6x to the 4th. What do I multiply this by to turn it into this? So you'd have to multiply by 2, and you'd need a couple of more x's to get up to x to the 4th. So 2x, a couple of more x's on that power. So now remember, each time you get a new term in your quotient, you're going to multiply it by the entire divisor, not just that first term. You're going to multiply it by the entire divisor. So you're taking that 2x squared that you just came up with and multiplying it by 3x squared minus 2x. That's what you're going to see me doing now. Okay, so that's going to be 2x squared times 3x squared is 6x to the 4th. 2x squared times negative 2 is going to be negative 4x cubed, your x cubed term. 2x squared, and now we have to do, okay, so I did all of my multiplication. And now we're on to subtraction step. So we're going to be subtracting that entire bottom row, which just means nothing more than switching the signs of each of the terms and then combining it. That's always what you do when you're subtracting a polynomial. You end up just switching the signs and combining it with the expression you're subtracting it from. So this combined with this, now that I've switched the signs, that's gone. Positive 5 combined with positive 4, that's why you should circle them so you don't accidentally use the old sign, would be 9x cubed. And don't forget to bring down an extra term. Okay, bring down that extra term, even if it's a 0x squared, and you're going to go again. Okay, so again, we're going to ask ourselves, what do you multiply 3x squared by? What do I multiply 3x squared by in order to turn it into 9x cubed? And the answer to that will be your next term in the quotient. You'd have to multiply this by 3, and you'd need another x on here to turn it into 9x cubed. So you're going to be multiplying by 3x. The minute that you get a brand new term here, you're going to take that brand new term and multiply it by everything in the divisor. That entire expression, 3x squared minus 2x. That's what you're going to see me doing now. 3x times 3x squared is 9x cubed. 3x times negative 2x is negative 6x squared. And then we're into our subtraction step. We subtract, and then we bring down that extra term. I'm not going to keep writing term because I'm running out of room here. Okay, subtraction means switch all the signs in the bottom row. And minus 9x cubed, that leftmost column is gone, and that should always happen. Otherwise, that flags you to the fact that you've made a mistake when you decided on the sign up here. Or the power for that matter. 0 plus 6 would be 6. And then don't forget to bring down one extra term, the term next to it. Okay, start all over again. So again, leftmost term here, we're comparing it to the leftmost term here. So I'm asking myself, what do I multiply 3x squared by in order to turn it into 6x squared? And the answer to that would be that I just multiply it by 2. So I'm going to put a 2 here. And after I get the 2, I'm going to take that 2 and multiply it by the entire divisor. So 3x squared minus 2x. Okay, let's do that. 2 times 3x squared, 6x squared. 2 times negative 2x, negative 4x. Now we're into the subtraction and bringing down an extra term. Okay, so we're going to switch, combine. This combined with this goes away. 3 plus 4, 7x, and then bring down that extra term. Then you ask yourself, is there any way to go from x squared, 3x squared, is there any way to multiply this by something to turn it into this? And there isn't. As soon as you see that this degree is less than that, then you can no longer go any further. Because if you're going to multiply this by some number, even if you just multiplied it by a number without any x's, you're still going to have x squared. That's never going to match up with this term. So that means you cannot go any further. So this entire thing is your remainder. This is your quotient. And then, of course, you know this is the divisor. This is the dividend. So when you go to give your solution, quotient is, abbreviate here, 2x squared plus 3x plus 2 plus a remainder of 7x minus 5. It is written as a fraction, and the denominator of your remainder will be that divisor. 3x squared new x. And that is your final solution. Okay, so a couple of examples of long division. Now we get into division that is much easier to use, but as stated earlier, this is appropriate for when you're doing division by something that's first degree and then a constant. And you're going to be really looking at that type of problem, and so that's why synthetic is appropriate for what we're going to be doing heading into graphing, you know, just working with doing various kind of problems with polynomials. Okay, so finding the quotient by synthetic division. Now this is an entire different procedure. You get rid of the variables while you're doing the division, so you don't have as much, you don't have as many terms hanging around. Much simpler. Okay, what you do here is, again, you need to arrange these terms in descending order. Make sure that they're in descending order or the answer is going to come out wrong. It is like that already. This is third degree, second degree, first degree, 0 degree. So we're good there. Also, there's no powers missing. It goes 3, 2, 1, 0. This is considered the 0 degree term. And you're dividing by x minus 3. So when you're doing synthetic division, all you do is take the coefficients off of each of these terms, and you're going to arrange them going horizontally. So it's going to be 1, 4, -5, and 5. 1, 4, and don't put them close together because you have to have room to do your work. Okay, so all you do is take the coefficients, 1, 4, -5, 5, and then you're going to be dividing by x minus 3. So you are going to deliver part of this divisor into this synthetic division box. Anytime the number that you're going to deliver here is attached to an expression containing, switch the sign of the number before putting it in here. Whereas you're going to see that the wording in some problems, the number is not going to be part of a binomial. It won't be. In that case, they will use wording like such and such a number is considered a 0 or a solution of the polynomial, and that's when you will not be switching it. But if they're asking you to do this by synthetic division and you're going to break this number apart from the x, you need to switch it as you break this bond here. So we're going to put a positive 3 in the box. So when you see a positive 3, that means it came from the factor x minus 3. Put a line right here, leaving space underneath these numbers, and you're going to drop the first one down, and you're going to begin multiplying. So basically, you're going to move in the shape of a V. You're going to multiply 3 times 1 and bring the answer right up in here. Okay, and I'll put like a little multiplication sign here. I'm going 3 times 1. That answer is 3. And then I'm going to add these two numbers. Do it again. Go 3 times 7. Bring that number right up here. 3 times 7 is 21. Bring it right up in there. Add. Okay, so when you add these two, you get 16. Okay, let's check the math so far. You always drop down the first number before you begin this multiplication process. Just drop it down. So 3 times 1 was 3. 4 plus 3 is 7. And then I went 3 times 7. I repeated this procedure. 3 times 7 is 21. Brought my product right up there. Added these, got a 16. Going in for the last step. Again, we're going to multiply by this number, always times the number underneath the bar. So 3 times 16 is 48. And then add these, and you get 53. Okay, in these problems, this last column, the number that you see in the last column underneath the bar, that's your remainder. Last column will always be your remainder, and this is your quotient, as though you had done long division. You just need to put the variables back on it. So every time you go through a synthetic pass, where you go through this whole process for a particular number, you down by 1 degree. So if you started off with third degree, you now have a second degree quotient. So this is going to be your second degree term. This will be 1 degree less than that. And if there's no sign in here, that means that it's a positive. If it is negative, you'll see a negative there. So your quotient is x squared, I'll just write it a little more clearly, plus 7x plus 16. Your remainder is 53. And remember, we write our remainder as a quotient. It'll be the remainder over the divisor, which was x minus 3. But notice that this is a lot easier than when you're trying to find a quotient by long division. Long division is exactly what the name means. It literally means it's a lot of steps. Okay, moving on to this next problem. We're going to be doing synthetic division again. I chose this one just so you would understand the significance of that you cannot have any powers missing. So whatever power your problem starts with, it should go down in increments of 1 with the rest of the power. So notice that the second degree term is missing. So when I go to do my synthetic division, when I go to string out my numbers horizontally, I'm going to go 5 for my third degree term. I'm going to go 0 for my second degree term. I'm going to go 6 for my first degree term. And these are just coefficients we're using. And then I'm going to use 8 for my 0 degree term. So this was coefficient of my third degree term. This is the coefficient of my second degree term, which did not exist. And you can put that in here, that second degree is missing. And so we have a space holder even when we're using this type of division, just like we did with long division. This is a space holder. And then 6 was the coefficient of my first degree term. 8 is the coefficient of my constant, or what we consider the 0 degree term. We're dividing by x plus 2. Again, when the number you're going to deliver to this synthetic division box, when that number is hooked to is part of a binomial, it's hooked to a variable, as you break this bond, you're going to switch the sign. And only then will you be doing it. If this was not combined with an x, you would use the sign as is without switching it. Okay, so now we need our line right here. Don't forget, this process starts by just dropping the first number down, and then you begin the multiplication. So it's -2 times 5. Bring your answer right up in here. So just moving in the shape of a V, multiplying as you do so, and then delivering your answer up underneath that next column. Then you will combine these. 0 combined with -10 is -10. Then it's going to be -2 times -10 is 20. Then you're going to combine these. That's going to be 26. And then -2 times 26 is -52. Then you're going to add this. Whoops. And that is -44. And remember, the last column is your remainder, whereas all of this is your quotient. But don't forget, you need to you can't just report the quotient as a string of numbers. You have to show that you recognize that once you go through a single pass of synthetic division, that you've brought it down by 1 degree. So if it started off with third degree, this expression is now second degree, meaning the highest degree is second degree. Then this will be the next highest degree, the coefficient of the next highest degree. And then this will be the constant, being each term is 1 degree less than the term in front of it. And then the remainder is -44 over that divisor, which was x plus 2, right up there in the instructions. Okay, the remainder theorem. The remainder theorem gives us a new way of evaluating a particular polynomial. Like when somebody gives you a function like this, if they were the way that you've been doing up until now, if somebody was to say, take this function and evaluate it at 5, you literally had to come over here and plug in a 5 everywhere you saw an x, deal with all of the powers until you finally got the answer. And you can do that easy enough in your calculator, but this remainder theorem says that if you do division, and if we divide this by x minus 2, then we are actually evaluating the polynomial at positive 2. So let me get rid of this just so I'm not confusing you. The number that they're asking you for in this particular example is 2. They want you to evaluate it to 2. And again, you could just plug in a 2 here and cube it, then plug in a 2 here and square it, multiplying it by -4, then put a 2 in here, multiply by 5, but then, you got a lot of work. You could also just do this. You could take this and divide it by x minus that value that they're talking about. The value they're talking about is 2, but what does that really look like if somebody was to tell you to take this polynomial function and divide by x minus 2? That you would simply be delivering a positive 2 right into this box. Then you would take your function and use the coefficients. Coefficient of the third degree is 1. Coefficient of the second degree term is -4. Coefficient of the first degree term is 5. Coefficient of the constant is 3. And I will get into showing you where you're actually getting the answer, but the remainder is the answer, which is why it's called the remainder theorem. It helps us to evaluate functions at certain values. Whoops, left one of those letters out. Helps you to evaluate functions for a particular value. Okay, so you probably understand this procedure is synthetic, so I'll just take a moment to further explain this. We were trying to evaluate this function at the value called 2. That is equivalent, according to this remainder theorem, of doing division. When you deliver this number to the synthetic division box, you know that you have to switch the sign, so it's basically that same number there. We drop 2 times 1 is 2. Bring that number right there. Add these terms and you get -2. Go again. 2 times -2 is -4. Combine those terms and you have 1. 2 times 1 is 2. Add these terms and you get 5. So being that I have pointed out to you that this last column is the remainder, that is actually the answer. In other words, this function right here, had you taken it and plugged in a 2 everywhere, you would have gotten 5 as an answer. Now we can always check that just so you can see that there is another way to get this answer. Does it really come out to be 5? We used the remainder theorem in order to get the answer. This remainder theorem says that that remainder is the same thing as if you would have plugged in the value that you've been asked to evaluate the function. And again, we can prove it to ourselves. We can take that function and do it the way we used to do it before we looked at the remainder theorem. When you usually evaluate something, you just plug it in for x. So it would be like this. It would be 5 times 2 plus 3. This would have been 8. This would have been 2 squared is 4. 4 times -4 is -16. This would have been a 10. This would have been a 3. Then you would have plugged all of that into your calculator. So 8 minus 16 plus 10 plus 3. Whoops, I didn't plug it in right. Okay, so 8 minus 16 plus 10 plus 3. And see, you get the same answer. Okay, so in the next problem, we're going to be taking a look at the factor theorem. And in this factor theorem, we're going to be using synthetic division in a way that's going to help us to find all the solutions for the function. So I've given you the theorem here, and basically what this theorem says is that whenever you have a remainder of 0, you have actually found one of the zeros of your polynomial, and that will help you to polynomial to get all of the solutions. So let me demonstrate that for you. It says use synthetic division to take x cubed plus 7x squared minus 9x minus 63 and we're going to divide it by x plus 3, and we're going to use the result to find all the zeros of the function. One of the zeros is going to come about just by doing the division. So remember, when you're doing this division, we switch any sign that is attached to an x, so that's going to be written in our little synthetic division box as a -3. We're going to take the coefficients, which are 1, 7, -9, -63. We're going to drop that first coefficient down, multiplying and then bringing the answer above the bar. So -3, bring it right up here. -3 times 1 is -3. Combine and you get 4. -3 times 4 is -12. Add these and you get -21. -3 times -21 is 63. Add these and you get 0. When this last column zeroes out, that means that you have actually found one of the zeros. The only way that the remainder is 0 is when this is an actual solution. And remember, you may get confused by the fact that we're calling it a 0, but zeros go by several names. It can be called a 0. It can be called a solution to the equation, and when you're graphing, it's called an x-intercept. It goes by any of those names. So when they use the word zeros, they're really just talking about solutions to this quadratic function. For this polynomial function. So I'm going to make a little solution set here. This is one of my solutions, which is, again, it's only a solution if it zeroes out, which it did. So -3 is one of my answers, and then let's try and tie this together. Every time you take a synthetic pass through this problem, you are bringing it down by 1 degree. It's also called decompressing the polynomial function. So it was 3rd degree. You've decompressed it to 2nd degree. So what you're seeing here is a 2nd degree expression. This is my 2nd degree term. This is my 1st degree term. This is my no degree term. If there's no sign in between the two terms, put a plus sign. In any event, what you now have is x squared plus 4x minus 21, and you still need to get some more solutions. This says find all the solutions. Zeros are the same things as solutions. And if this is 3rd degree, that means there's 3 answers. We only know about one of the answers so far. That means we still have 2 to go. So you're going to treat this as an equation zeroed out. So it'll literally be this equal to 0. And if you can factor this, factor it. And if not, you can use the quadratic formula. Now this factors because you can go 7 times 3 and get a 4 as long as you make one of them negative and one of them positive. So breaking up that x squared to fill in the front position of each parenthesis, and then breaking up, factoring down this 21 into 7 and 3. And the bigger of these two numbers gets the sign that you see in the middle there. So it's a positive 7, but a negative 3. You should be able to multiply these two numbers, just trying to remember the steps for factoring a trinomial like this. You should be able to multiply them to get the back number, but add to get the middle number. Okay, so it's all nice and factored, and then you can make little smaller equations out of each of these individual factors. That means you're using the zero factor property, that's called. When two things multiplied together are 0, that means one or the other was 0. Now solve this. Bring this negative 3 over to where the 0 is right here, and you get x equal to positive 3. So now we have another answer. And then bring this positive 7 over here, and we have x equal to negative 7 for our one answer through synthetic division. We found a second and a third answer through factoring. We brought it down to 2nd degree, and then we continued to factor what was left over, which was a 2nd degree expression. So all of the answers, these would be the 3 answers, also referred to as zeros. Remember, zeros means the same thing as solutions. When you're graphing, that means the same thing as x-intercepts. They would actually be the points on the x-axis for that polynomial graph, which we looked at in the previous section. Nice, smooth graph going through various x-intercepts, and these would be them. Okay, moving to the next example, we're going to be solving. This time they're not giving it to you in function form. They gave it to you in function form here. They're just giving it to you as an equation here. But notice that the wording is different here because students get tripped up on this. Here they pose it to you like this. They give you in function. They give it to you in function form and say, use synthetic division to divide by this expression right here. Notice that they're not saying that here. The wording is different, so you got to catch yourself. They're giving it to you as an equation, and instead of saying divide by this certain expression, x minus something or x plus something, you don't see the x here anymore. You just see them telling you already that this is already an actual answer. There are 3 answers, 3 solutions to this polynomial equation. They're saying this is one of them. Because this is not connected to an x, you will not be switching the sign when you deliver it to the synthetic box. You're still going to use synthetic. Okay? Only switch the sign if you are breaking the number apart from an x that it is combined with, as in this problem. And you would break this positive 3 off by switching the sign, delivering it to the synthetic box. So here you are not going to switch the sign. But you are going to use synthetic. You're going to put this negative 1/4 right in here, and you're going to stretch out your coefficients as you have in the previous problems. We're not missing any of the powers. 3rd degree coefficient, a 2nd degree coefficient, a 1st degree coefficient, and a 0 degree coefficient. Don't forget to put that line, leave some space underneath the numbers, and drop the first one down. If you need help with the multiplying because it's a fraction, then do it in your you could always do it in your calculator. Okay, so we're going to be multiplying 1/4 times 16. This is a negative, so you know that when you multiply this times this, it is going to be negative. Maybe you want to put the negative there first. If you need help from your calculator, you can just go 16 times 1 divided by 4. And you see you get a 4. So that times that is 4. Okay, add these up, you get a 12. Now you're going 1/4, negative 1/4 times 12. Negative times positive is going to be negative. And if you know what 1/4 of 12 is, then put it right here. It's 3, or put it in your calculator. Just 12 times 1 divided by 4, which is 30. Okay, now add these up. This combined with this is negative 4, and then 1/4 times negative 4. Negative times negative is positive. 1/4 times 4 is 1. And when you combine these together, you get 0. Every time your remainder is a 0, that's because this number is 0. But they had already told you that to begin the problem with, whereas they did not start this problem with that word, and you had to discover it yourself, that when you used negative 3, it actually zeroed out, and therefore this happens to be called one of the zeros. But in this problem, they told you, hey, you can expect for this to zero out because this number that you're using in the synthetic division is actually called a 0. So this is one of the answers in your solution set. Now it said solve the equation. That always means find all solutions. So there's the one they gave you, and dividing by that particular 0 enabled you to knock down to a 2nd degree expression. It was 3rd degree. Now you're at 2nd degree. This term's 1 degree less than this. This term's 1 degree less than that, meaning it has no zeros. You can fill in this blank spot with a positive because if it did have a sign, you would see it there. And then you're going to continue. See if you can factor. 12x minus 4, you're treating it as 0. Notice that there is a common factor here. 4 goes into all of these. So just to make these numbers smaller and more manageable, I'm going to divide this all the terms on this side by 4 as well as all the terms on this side by 4, just as long as you're dividing both sides by the same number. So this will be 16 divided by 4, 4. And of course they carry the variables that are with them. Negative 4 divided by 4, negative 1. 0 divided by any number, 0. And then we try and factor this. If we can't factor it, we will find the remaining answers by quadratic formula. So let's see what happens here. You have to mess around with this a little bit just because this is not a one that'll make your thought process a little bit more involved while you're factoring it. So there's two different ways to break up this first term. You can either go 4x times x or you can go 2x times 2x. And that is really the basis of why this method I'm using to factoring is called guess and check, because you have to consider guessing at which one's going to work and then messing around with that until you find the numbers that work. You're not going to have that many possibilities. I'm going to try the 4x and the x specifically because I can see I need a 3 and I'm going to have 1s back here, because the front positions get broken up using factors of this term. So this is one of the factors, this is the other factor belonging to 4x squared. Then the factors of 1 are just 1 times 1. Okay, now one of these is going to have to be positive, one of them is going to have to be negative. So the bigger product is going to come from here, if you understand FOILing. 4x times 1 is going to give you a 4x term. I'm going to let that be my positive term, my bigger term. This is going to be my smaller term. I'll let that be negative, and that'll give you the 3x. See? And you can even see when you practice FOILing that you have factored this properly. And you can check it. 4x times x is 4x squared. 4x times 1 is 4x, just to make sure we're getting that middle term, to make sure we factored right. And then negative 1 times x would give you negative 1x, and there you go, there's your 3x. And then negative 1 times negative 1 is that. So yeah, we have factored properly. Now we're going to go in for the second and the third answer. One was given to us through factoring. Okay, so you set each of these factors equal to 0. Okay, bring this negative 1 over here, and it's positive 1. Divide by 4, and we get x is equal to 1/4. So now we have another answer. And then here, this one's super easy. Bring the 1 over here, and you get x is equal to negative 1. So we have positive 1/4 as an answer, as well as negative 1. And those are all three of your solutions. Okay, moving to problems where they're trying to get you to combine what you learned in the last section with what you're learning now. So we were graphing polynomial functions in the previous section, and we took a look at the fact that when when the graph hits the x-axis, that is called an x-intercept. True. But anything that has anytime you go through a point on the x-axis, like for instance, this is 1, 2, 3, 4, 5. This is actually the number 2, 0. Not only is this x equal to 2, not only is that considered an x-intercept, but it is also considered a 0 or a solution. You could call it a solution also of the function that you're working with. Now they've given it to you in equation form, and you already happen to know that this 2 right here is an actual solution to the problem. So which solution of the equation can be determined from the graph? This number right here. We know that it's 0 because its y-partner is 0. Anytime something's an x-intercept is an actual solution to the problem. So positive x equal to positive 2 is a solution. What are the other? You just learned that if you already have one of the zeros, one of the solutions, that you can bring that polynomial down a degree and then factor the other two. That is what the last two examples just illustrated. So just continue. It's just that this time you're being given the zero, or what's called a solution. You're being given it in the form of a graph. So the rest of the procedure is no different. If you already know one of the answers, don't switch it. Put it in there as is. We already happen to know that 2 is a solution, so we're going to keep that in mind when we give our 3 solutions, because this is third degree. We're going to string out those coefficients as 1, 8, -4, and -32, making sure that none of the powers are missing, but they're not. Third degree, second degree, first degree, 0 degree. We'll put that line underneath there, and we're going to bring this thing down to second degree. We already know that this is going to make it 0 out, which is why it's called a 0. So bring this down. It's 2 times 1 is 2. Add these up, get a 10. Then it's 2 times 10 is 20. Add these up, get a -16. Then it's 2 times -16 is -32. And let's see. X cubed plus 8x squared minus 4x minus 32. So 2. See. I copy this 1, 8, -4, -32. Okay, I see what I did. I knew something was wrong there. When I added this up, this should have been +16. Okay, so 2 times 16 is +32. Add those up, you get a 0. So there you go, you zeroed out, and that right away brings your equation down from third degree down to second degree. This is your second degree expression, 1x squared, and x, and +16. You can put a plus in there. And then let's take this x squared plus 10x plus 16, and just treat it as a second degree equation that we are looking for the solutions for. Okay, now you're going to factor it, breaking up that second degree term as x times x, and breaking up the back number in a manner that will multiply, 2 numbers that are multiply to give you 16 but add to give you 10. That would be 8 and 2 as opposed to 16 times 1 or 4 times 4. So 8 and 2, they're both going to be positive. This times this is 16, but this factoring of this polynomial right here. Now make your little smaller equations and then into that second and third solution. So bring this, and you're into x equal to -2. Bring this over here, and you're into x equal to -8. So there you go. You have all 3 solutions. The one that was given off of the graph, and then the other 2 that you got through synthetic division and factoring, which are -2 and -8. Okay. Use a graphing utility to graph the polynomial function defined by the left side of the equation. So we're going to be putting this into our graphing calculator, and make sure to use end behavior to make sure you have a complete graph, because in these kind of problems, when you're in my math lab, they're typically going to give you 4 different graphs, and you have to pick which one is appropriate. So you want to really pay attention to what are the x-intercepts that your graphing calculator is showing you, and what do you know about the ends. We talked about when we were graphing in the previous section that that you look at the highest degree and the leading coefficient. When it is odd degree, as we looked at in the previous section, and this is negative, you can expect the left to go up and the right to go down. So be looking for that, because sometimes you blindly go and put all of these into your calculator and you don't realize that you have chopped off one of the sides of your graph because you don't know what to expect. You don't know any of the background theory, so you just think, hey, whatever is in my graphing window, I'm just going to take it for what it is, and you end up getting it wrong. Behavior, which is why it is mentioned in this problem, could help you to understand, hey, I need to adjust the window in my graphing utility, my graphing calculator, so that I'm actually seeing the entire graph so that I pick the correct graph in my math lab. Okay, so it all goes together. We know that this is from section 3.2, that kind of leading coefficient theory. Okay, so when we go in here and we try to put all of this into our graphing, 2x cubed plus 12x squared minus 10x, and let's see, let's keep messing with the window until we get the ends to look like that so we have a nice full graph and we can see all the x. Don't forget to press enter after you put that whole thing in. Right now I think I'm going to use a standard window. I'm going to go to zoom, standard, and then I'll see if any of my graph is chopped off. Because it's a lot easier to see where your graph is hitting. And remember, with respect to this problem, we just need to be able to see the x-intercepts. You can already see that this graph is behaving exactly as we predicted right here. The left side is going up, the right side is going down. And because we've chosen a standard window that goes from negative to 10 to positive 10 on the x-axis, we can pretty much see the x-intercepts. If you want to be able to see them even more clearly, instead of having so many numbers, because there's 20 numbers here, negative 10 to 10, you could put less numbers. You could go negative 5 to 5 on your x-axis, and then you'll more clearly be able to see the x-intercept. So why don't we do that? Let's go into the window, and we're going to manually adjust that the parameters on the x-axis. So we're going to go to x-min, make it a negative 5. We're going to go to x-max, make it a 5. Now, and there you can see that it goes through 0, it goes through 1, and it goes through, if you want to give yourself more room because you're not sure where that's hitting, you could go window and take it out to, 6 or 7 if you want. I'm going to go 6. Okay, goes through 0, goes through 1, and yeah, that goes right through 5 because this is 6 out here. So 0, 1, and 5. And there we go. Not only can we see those x-intercepts, but understanding that the x-intercepts are also the solutions to this equation, or what we call zero. The answers, and we got away without doing any synthetic or anything like that because you were given permission to use your graphing calculator. Okay, moving to the last couple of problems in this section. We have just a repeat of some of these problems just to solidify it for you. It says use synthetic division to divide x cubed plus 7x squared plus 9x plus 144 by x plus 8. I just want to make sure that you have this down, that when you are finding the solutions and the question is posed to you like this, where they're saying use synthetic division to take this and divide by an expression, that is when you are going to switch the sign of this number before delivering it to the synthetic division box. So it's going to be negative 8. You're going to stretch out those coefficients, which are 1, 17, 90, and 144. Third degree, second degree, first degree, 0 degree. No powers are missing. Always drop down that first number below the bar and then begin the multiplication. Negative 8 times 1 is negative 8. Add these up, you end up with a 9. Negative 8 times 9 is negative 72. Add these up. 90 minus 72 is 18. And then negative 8 times 18, that is negative 144. So you have 0 for a remainder. And therefore, you have an expression which you can continue to factor to find the other two solutions. Right now, I have already found one of the zeros. I know that this actual answer is a solution because it made the remainder 0 out. That's when you know that you have actually found a solution. So I got one of them happening already. I'm going to Consider the fact that this was a third degree function. I've now decompressed one synthetic pass through this problem. So it's second degree, first degree, no degree, or 0 degree if you want to call it that, because that is what it's called. And we're going to just continue here. We're going to see if we can factor this. So we're going to consider this like a second degree equation. Breaking up the x squared and delivering that to the front position of each parenthesis, and then asking ourselves what times what two things can we multiply to get 18? That would be 6 and 3. Those multiplied give us 18, and when added they give us 9. So we have successfully factored that. We're going to make one equation out of the factor x equal to 3, and we're going to make another equation out of the factor x plus 6. Bringing this over here, we have x equal to negative 3. So we have our second solution. Remember, there are 3 solutions because this is third degree. And when we bring this over here, we have x equal to negative 6. And there we go. We have all 3 solutions. Okay, moving to the last problem in this section. I just threw a couple more of these. One where you did have to switch it because the number was connected to the x, part of a binomial, and one where you do not have to switch it. And this one uses a new word for you. So, as a fourth way to say that you are actually dealing with an answer to the problem, again, you can call it a solution. You can call it an x-intercept when you're when you're graphing. You can call it a 0, and I have introduced these words over and over again in this section, but you can also call it a root. You need to be familiar with these terms so you don't think you're being given a different type of problem. But anyway, this particular number, unlike this problem, is not attached to an x, so you don't have to break it apart from some binomial that it belongs to, because they're not giving it to you like that. They're saying this is an actual solution as is, and I wanted you to get some more practice with your fractions. So 1/3 is out there. You could always use your calculator if you're not good with multiplying by a fraction. Take those coefficients and spread them out. There's your third, your second degree coefficient, your first degree coefficient, and your constant. Bring that line, leaving space underneath the numbers. Bring the first number down, and it's 1/12, which is 4, or you can just put it in your calculator. You could just go 1/3 times 12, and you can press it in. There's different ways to press it in. You could just go, you can put the fraction in first if you want 1 divided by 3 times 12, bing, 4. Okay, now add these up. So it's 4 minus 61. You're combining a positive 4 with a negative 61, and you get negative 57. Okay, again, you're going 1/3 times any number that's below this bar, and then bringing it up here. That is a 57. Okay, so if you want to put that in your calculator, it's 1/3, just 1 divided by 3, that'll give you the fraction, times that negative 57, and you get a negative 19. So 1/3 times negative 57 is negative 19. Combine these two numbers, you get negative 15. And then 1/3 times negative 15, again, you can put it in your calculator, but you're going to get negative 5. 1/3 times negative 15 is negative 5. And there you go. You have your problem zeroing out, meaning that this can actually be factored to get the other solutions, and also implying that this is an actual solution to the problem. So your solution set is 1/3, and we're about to get the other two answers by factoring. If we can get the other two answers that way, otherwise we might have to use quadratic formula. So here we go with that. Okay, we're going to go, and remember, you've brought it down to second degree, so this is second degree, first degree, no degree. So it's 12x 4x squared minus 57x minus 15. You can try to make those numbers smaller if there's a number that goes into each of these coefficients. Let's see if there is. We can divide maybe 3 into each of those because we have been multiplying by 1/3, which means they're divisible by 3. So this would be, instead of such a big coefficient, it would be 4x squared. And if we go 57 divided by 3, that would be 19. So you would have a negative 19x in the middle. And negative 15 divided by 3 is negative 5. Okay, so these numbers are sort of creepy because they're just, bigger. But you don't have the 1x squared, which makes the factoring a lot easier. But let's go ahead and try to factor this. So when we go to fill in the front position of each of these, we can either break this up as 4x times x or 2x times 2x. Now since we're going for such a big number in the middle, I'm tending to think that I want to stay with the 4x, have like bigger numbers for breaking this down. And then when I go to do this, the only way, and when I go to fill in the back position, that's just a matter of what are the factors of this number. Here I had a choice of 4x times x or 2x times 2x. I went with this. And now to get that 19, I'm going to put the 5 in the back because that'll get us up to 20. And then I want to bring it down 1, which is what this 1's going to do. I want the bigger product to be negative, so that 4x times 5, there's two products that come out of this. The 20x and the 1x both contribute to this middle term when you're foiling. So I'm going to let that be negative 20, while this will be positive 1. And you can always check that real quick by foiling. Foiling is how you check whether you have factored something properly, and we have. 4x times x is that 4x squared, and then that tricky middle term comes from two different pieces. 4x times negative 5, which would be negative 20x, and then the other part of that negative 19, it comes from right here, plus 1x, which, there you go, there's that beautiful 19, negative 19 in the middle, and then that negative 5 is from that times that. We factored it beautifully, and now we can make our little linear equations out of these factors. So here we would be bringing the 1 over here, that would be negative 1, and then we'd have to divide by 4, divide by 4. So another solution here after these 4's cancel would be negative 1/4. And then this solution would just simply be 5. Okay, and those are all 3 of our solutions. And that completes section 3.3, the remainder and factor theorems. So sorry about my dogs barking in the middle of the video, but sometimes it happens. Okay, see you for the next section.